Hi everyone, welcome. I'm just going to give it a couple minutes just to let viewers start signing on. In the meantime, you can just hang out, hopefully enjoy the music. I'm playing in the background, and there's also a chat available if you're on a computer. I don't think it's accessible through a phone, but if you're on a laptop and you see the chat box, feel free to say hi and where you're viewing from, and yeah, just hang out for a bit, and then maybe in 3 minutes I'll go ahead and start. So if any people are joining right now, I'm just going to give it a few more minutes just to let people sign on, since I just literally started the live stream. And as a forewarning, there is kind of a few second lag from when I'm recording to when you watch it. Just in general, if you're ever typing in the chat, again, I just mentioned, I think the chat you can only access through a laptop. I'm not sure if you can access it through your phone, but feel free to, at any point in the show, to send something in the chat if you have any questions, or just say hi right now and where you're viewing from. Is the echo gone now that I stopped playing music? Or can you also hear it when I speak? Okay, hopefully there isn't an echo. Please let me know if there is on the chat, but I'll go ahead and get started now. Oh, the echo is still there. That is interesting. Okay, let me... What about now? Okay. Well, what I can just do is, let me change the microphone, and hopefully that helps. And then I'll use my laptop microphone instead. Okay, so hopefully the echo is gone. Please let me know, but I have changed microphones, so hopefully that helps. Okay, so I'm going to go ahead and start, since it is 7:04. So welcome everyone, and today, welcome to our show where we are going to be celebrating Black History Month today. Okay, it's better now. Thank you to those in the chat who helped out with that. So for those who are not familiar with the UCLA Planetarium, the UCLA Planetarium is run entirely by graduate students, and I am a second year PhD astronomy astrophysics student at UCLA, and I am one of the coordinators. There are 6 of us who coordinate the UCLA Planetarium, and essentially we organize the shows, and we organize the shows and have graduate student volunteers, sometimes postdocs, and sometimes even undergrads host a show of their topic. But the 6 of us as coordinators are also working to develop more inclusive shows, and this is part of that series. Also, I totally forgot to introduce myself. My name is Elizabeth Villafana, as I mentioned, a second year PhD at UCLA. And kind of just wanted to give a brief message about what our goal is as the UCLA Planetarium. Since we are graduate student run. We are essentially the next generation of astronomers, and we believe that as the next generation of astronomers, it is our responsibility to work on creating a more inclusive environment, and especially since we work on this on like science communication and outreach events through these shows, we also hope to inspire future generation of minority astronomers. Specifically in like this show in particular, I hope to show future generation of astronomers that I hope to inspire them by them seeing astronomers who look like them, and hopefully build a better future in the astronomy community. And this month we are doing that specifically by amplifying the voice of Black astronomers and highlighting the work. This show in particular we will be looking at historic astronomers, so just astronomers and physicists from the past. But in 2 weeks, on February 16th, we will be highlighting the work of our Black colleagues at UCLA and in the greater Los Angeles area, so you'll definitely want to join that too. And as part of the inclusivity series, we also will be looking to create shows for Women's History Month, Hispanic Heritage Month, and hopefully also shows in different languages. So if you follow us on social media, on our Twitter page or Facebook page or our website, you'll see those updates as they come along. But I'll go ahead and begin. And the first Black astronomer I'd like to bring up is Benjamin Banneker. He's basically regarded as one of the first African American scientists. He was a free man in the 18th century and was largely self-educated and owned a tobacco farm near Baltimore. And he's also credited for building the first clock. In 1761, he had built a wooden clock that kept precise time. And he was a self-taught astronomer. His neighbors gifted him different tools as well as books, and he taught himself, and he built a shed and carved out a skylight, so like one of those windows, and turned that shed into an observatory. And he started sleeping in the day so that he could make observations at night. And using advanced trigonometry, he constructed accurate tables and accurately predicted an eclipse that would occur on April 14th in 1789. And his prediction beat those of many of his contemporaries at the time. And in addition to eclipse predictions, he also calculated the timing of tides, the time of sunrise and sunset throughout the year, different phases of the moon, and seasonal changes. And he published his calculations in an almanac, which at the time was very important to basically the entire world. I found like online that most people at that time owned 2 books, a Bible and an almanac. And he published his first almanac at 1792 and continued to publish one annually until 1802. And in the almanac, he included all his astronomical calculations and included tips for planting crops, ideas for medicine, and inspiring quotes from literature. He also sent a copy of his first almanac to Thomas Jefferson, who at the time was Secretary of State, and wrote him a letter asking him to help bring better condition for Black African Americans. And Jefferson shared this almanac with European scientists who praised its accuracy. So again, he's widely regarded as one of the first African American scientists and was a self-taught astronomer. And moving on to the next astronomer I'd like to focus on is Harvey Washington Banks. He is the first Black American scientist to earn a doctorate degree in astronomy, in that he earned his degree in 1961 from Georgetown University. His research interests included orbital and celestial mechanics, but he's mainly known for 2 of his major contributions. The first one is his advances in spectroscopy, which is how astronomers use light to study properties of different sources. So if you're not familiar with spectroscopy, about 2 weeks ago, one of our graduate students named Leonardo hosted a show in which he discussed how astronomers use light to learn things about the universe. So I would definitely check that out if you're curious about it and learn more. It's still on our channel. And but the second other contribution of Harvey Banks was his work in geodesy, which is basically measuring and understanding Earth's geometric shape and its orientation in space, and as well as its gravitational field. And thanks to him is why you're able to make it to work in the morning, or at least myself. I cannot make it to work without a GPS, or cannot make it anywhere without a GPS. So his work in geodesy played a big role in the GPS technology, and many aspects of it are still used in our GPS systems today. And again, he was the first Black American to earn a astronomy PhD, and that was in 1961. The next astronomer I'd like to talk about is Ronald Mcnair. If you're familiar with the undergraduate Trio Mcnair Scholars Program, you may not have known it's actually named after a physicist named Ronald Mcnair. If you have not heard of this program, it is a federally funded program that's meant to support and prepare historically underrepresented groups for doctoral studies. So, and it's pretty cool that it's named after him. He received his PhD in physics from MIT in 1976. And after MIT, he became a staff scientist at the Hughes Research Lab in Malibu. And he's nationally recognized for his work in laser physics, but he's also more known for being the second African American to fly in space. He flew as a mission specialist on the first flight of the Challenger space shuttle mission in 1984. And he was also, aside from being a physicist, he was also an accomplished musician, and he intended to record a saxophone solo during his second mission. And he would have been the first original music recorded in space. Unfortunately, however, he died during the Challenger launch in 1986, where he was serving as one of 3 mission specialists in a crew of 7. If you do not remember the Challenger failure, if you were not around like myself, it was in 1986. The Challenger had a launch booster failure that ended up leading to a vehicle disintegration during launch. And unfortunately, those 7 crew members lost their lives during that day. And moving on to the next astronomer I'd like to talk about is Arthur Walker. He was a solar physicist and a pioneer of UV and X-ray optics. He earned his PhD from the University of Illinois in 1962, and then joined the aerospace, he joined the Air Force, where he worked on satellite instrumentation to measure the Van Allen belt radiation in Earth's magnetic field. If you're not familiar with that, don't worry. I'm also in this show forgot to mention that I will cover some of the science aspects of their work. So that was how he started his science career. And then from there, he transitioned a few years later in 1965 to the Space Physics Laboratory of the Aerospace Corporation, where he used rocket technology satellites to study the sun's atmosphere instead at ultraviolet and X-ray levels. And then in 1974, he became a professor of physics at Stanford and was chair of the astronomy program from 1977 to 1980. During his time as professor at Stanford, Walker mentored 13 graduate students, and most of which were from underrepresented groups. Also noteworthy is that his first graduate student, Sally Ride, went on to become the first American woman in space. And he set up an informal advocacy association with other Black faculty members called the Banneker Group. So if you remember the first scientist I spoke of, Walker created a group and named it after Banneker. And while at Stanford, he developed and launched a solar observing rocket, and this was the first to obtain a high-resolution image of the sun's corona at extreme UV wavelengths and X-rays. And this technology is now used in solar telescopes such as the Solar and Heliospheric Observatory, called SOHO for short, and the Transition Region and Coronal Explorer, called TRACE for short, as well as the fabrication of microchips. He was also instrumental in building congressional approval for the National Solar Observatory and served on the Rogers Commission that investigated the explosion of the Challenger space shuttle, on which Ronald Mcnair died. And so now moving on a bit to some of the science that Walker studied. So the Van Allen radiation belt is this zone of energetic charged particles that are captured and held by Earth's magnetic field. Most of these particles originate from the solar wind. So they're like particles that are released from our sun, and some are thought to come from cosmic rays. Earth has these two belts that extend from 400 to 36,000 miles above the surface, and they vary in radiation levels. So this GIF that you see on the right here is kind of just showing the different radiation. The different colors represent different intensities of the radiation in those belts, and sometimes more belts are temporarily created, and essentially our magnetic field traps these wind particles, and in this way deflects them from entering our atmosphere and protects us. But it does it is dangerous for satellites, because any satellite that passes through this region and spends a long time there needs to have adequate shielding for sensitive components. So it makes sense why when Walker started his science career, he was doing research for the Air Force, and it makes sense that the Air Force would be interested in measuring the radiation levels, just because it is dangerous for satellites technology. And the other thing too is that, as I mentioned, these particles come from the solar wind. So essentially from this work that Walker did, it sparked his interest in solar physics and all the work he did afterwards, which would involve capturing the first image of the solar corona. So the solar corona is the outermost atmosphere of our sun. If you've ever had the opportunity to see a total solar eclipse, which they're super cool, I was able to see one in 2017. The solar corona is during the time of totality. You can actually, and when you're able to take off your glasses, it's the outermost part of the sun. And as I mentioned, Walker was able to capture the first image. On the left there is the image that he captured with his telescope that appeared on the cover of Science magazine in 1988. And then in 1991, he launched 14 telescopes on NASA's Multispectral Telescope Array. And then in 1994, on the second flight, he launched 19 telescopes. So you might be like wondering why he needed so many telescopes to capture this image, right? And if you're like from an engineering background, maybe you might be thinking like maybe for redundancy, like in case one fails, but that wasn't the case. The reason why is that a telescope filter only lets in one wavelength at a time, which means you can only look at one temperature of the sun at a time. That's because different temperatures correspond to different wavelengths or peak at different wavelengths. So for example, humans, we emit in the infrared. We just can't see that kind of light. So if you've ever seen Predator and you see like how he sees humans in infrared, it's because our body temperature peaks in infrared. Or if you've been to like a science museum and they have like, sometimes you can see yourself in infrared. So essentially that's the same idea in general. Different temperatures will peak at different wavelengths. So what Walker wanted to do was that he wanted to look at all the different temperatures of the sun. So in order to look at all the different temperatures at different heights in the sun, you need to look at be able to look at different wavelengths, and that's why he launched 14 on the first flight and 19 on the second flight, so that he could look at multiple wavelengths at the same time. And the reason for that was to try to better understand the sun's activity. The corona is 1,000 times hotter than the sun's visible surface, and this is actually still pretty puzzling to scientists today. It's an active area of research still. The sun is heavily studied. If you're familiar with the more recent solar probe, the Parker probe, so it's still an active area of research and still not entirely well understood. And as I mentioned, the solar wind is high energetic particles that come from the corona. just because, how I said, it's very hot, 1,000 times hotter than its visible surface, and it releases those energetic particles that form the radiation belts right around Earth that we just discussed, and also that is also what causes auroras. So so you can see auroras closer to the North Pole and the South Pole, and that's because there are those gaps in the magnetic field at the poles, and there those energetic particles can enter, and then when they enter Earth, they interact with the atmosphere, and that is what produces those really pretty colors in an aurora. In addition to that, the particles that's released by the corona, the very hot, violent corona, also can mess with our telecommunications and power and radar and weather. So it's also another reason why it's a heavy interest for like the military and Air Force as well. Okay, moving on. Again, if you have questions at any point, please feel free to type it in the chat and I'll try to answer to the best of my ability. Moving on to Beth Brown. Beth Brown was a NASA astrophysicist with a research focus of elliptical galaxies and black holes. She was the first African-American female to earn an astronomy PhD from the University of Michigan in 1998. She used NASA's Rosetta X-ray satellite and the Chandra X-ray Observatory to collect data on elliptical galaxies. While at the University of Michigan, Beth gave tours at the local planetarium and developed a one-credit course in naked eye astronomy for students with no astronomy experience. And the course still exists today and is very popular. She basically just wanted to spread her joy for like looking up at the night sky and just astronomy in general. And what I really like this quote here on the slide, that was when asked what she felt was her greatest achievement, she replied, convincing a young woman not to give up on her dreams and becoming a scientist because someone had told her she couldn't do it. So she was a very inspiring, motivational woman as well, and in addition to all the research she did. And as I mentioned, her research was on elliptical galaxies, which she used the NASA's Rosetta X-ray satellite and Chandra X-ray Observatory to collect more data on the environment of these types of galaxies. So our galaxy is a spiral galaxy, and elliptical galaxies are thought to be the result of two smaller galaxies merging, and is believed to contain a supermassive black hole in its center. Elliptical galaxies shine bright in the X-ray region of the electromagnetic spectrum. So as I mentioned, different temperatures correspond to different wavelengths of light. So the X-ray corresponds to very, very hot material, about 10 million degrees hot. And here, as you see the X-ray image, it's actually not visible to our eyes. Some astronomy pictures in different wavelengths are usually just modified so that we can interpret it. And a couple more comments on just galaxies and supermassive black holes, which were her research interest. The idea that elliptical galaxies is a result of two smaller galaxies merging together is actually what is expected to happen with our own galaxy. If you're familiar with the idea that, or with the fact that Andromeda and Andromeda, the nearest galaxy near us, and the Milky Way are on a crash course. The idea is that in 5 billion years from now, they will collide and end up forming one big elliptical galaxy instead of a bigger spiral. And another fun fact with that is that even if we were still around at that time, if humans were still around, there is so much space in space that the collision would likely not have any effect on our solar system. There probably would not be a collision with anything else. There's really cool videos that always try to explain the amount of space even within our solar system, so I would check those out. But that's a fun fact. The other fun fact too has to do with the supermassive black holes. So the launch of Hubble Space Telescope in 2000s led to the discovery that we now think there's a supermassive black hole in every galaxy, and these are different than what you probably think of when you think of a black hole. You most likely think of a stellar black hole, which are the ones that if you've ever watched the movie Interstellar, the one that those two planets orbit, and it's usually, we know what creates those, and it is the death of a massive star that creates a stellar black hole. On the other hand, with supermassive black holes, we do not know what the seeds are or what forms them. That is still an active area of astronomy research today, and in addition to that too, another active area of research is its role on the galaxy. They're thought to affect one another. Anyways, I will move on. This is hitting really close to my own research, and if you've ever heard about, sometimes people will say if you don't know what to talk about with a professor or a researcher, bring up their research topic and they will not stop talking. That is definitely what is happening here, since this research topic hits really close to my own research. So I will move on, and the next person is Claudia Alexander, who was a Canadian-born Black American research scientist who specialized in geophysics and planetary science. She actually received her master's from UCLA, where she used Pioneer Venus data, which was an orbiter, to study the UV radiation in Venus's ionosphere and its interactions with the solar wind. So everything we just mentioned about the particles coming from the corona and the solar wind and the way it creates the radiation belts. It happens with the rest of the planets too, and there are aurora on other planets in our solar system. So that was what her work at UCLA was in regards to, and then she earned her PhD in atmospheric, oceanic, and space sciences from the University of Michigan in 1993, where she specialized in space plasma physics. She then began working at NASA's JPL, the Jet Propulsion Laboratory, in the late 1980s, and she's primarily known for working on 3 big missions. The first one was the Galileo Spacecraft. She was the science coordinator for the plasma wave instrument, and then later became the project manager during its final phase and oversaw the spacecraft dive into Jupiter in 2003. Then she worked as a science coordinator on the Cassini mission to Saturn, and from 2000 until the time of her death in 2015, she served as a project scientist for NASA's role in the Rosetta mission. She was also a strong advocate for women and minorities in STEM and a passionate science communicator. She mentored young people, particularly young girls of color, to encourage their passions for science. So briefly to discuss some of the work she is most noted for, or the missions that she had roles for with NASA. The first one is the Galileo mission, which was launched in October 1989 and entered orbit around Jupiter in December 1995. Some of the noteworthy discoveries are that it completed the first flyby and imaging of an asteroid, Gaspra, and then later Ida, and it discovered 21 new moons around Jupiter. It also discovered a global liquid ocean under the icy surface of the moon Europa, and also magnetic data that it collected suggests Ganymede and Callisto likely have a liquid saltwater layer. Ganymede also has a magnetic field, which is the first moon known to have one. Jupiter has thunderstorms many times larger than Earth. Io's volcanic activity may be 100 times greater than that found on Earth, and the heat and frequency of eruption are reminiscent of early Earth. And then also learned a bit about Jupiter's ring system as well, and was the first and is most known for being the first spacecraft to orbit an outer planet and the first to deploy an entry probe into an outer planet's atmosphere. Then Cassini-Huygens mission, which she worked on, possibly my favorite of interplanetary missions. It was launched in October 1997 and entered orbit around Saturn in June 2004. I think it originally had a lifetime of 4 years, and it was extended twice, and ended up studying Saturn and its system for over a decade, and until it plunged into its atmosphere in September of 2017. Some of its notable discoveries, which there were a lot, so it was very hard to choose just a few. Again, though, I may be biased since it's one of my favorites. It was a joint collaboration, also if not familiar, it was a joint collaboration with the European Space Agency, or ESA, with the Huygens Probe. The Huygens Probe was the probe that landed on Titan, one of Saturn's moons. So there was a lot of discoveries. Some of the noteworthy ones are the active icy plumes on Enceladus, and that Saturn's rings are active and dynamic. That was not known before. And it also provided the first view of the North Polar Hexagon and the discovery of the giant hurricanes that occur on Saturn's poles. And before Cassini, the Cassini mission began, scientists knew of 18 moons around Saturn, and then while it was en route, they learned of 13 more, but we now know that it has 53. So if I'm doing my math right, it learned, yeah, if I can math, it basically discovered 20 new moons, which is a lot. And also, one of the bigger discoveries as well was with the Huygens Probe. It discovered that Titan has methane lakes and collected the first extraterrestrial ocean sample, which is very, very cool. And the third mission that Claudia worked on was the European Space Agency's Rosetta mission, which purpose was to study and land on a comet, the comet 67P. I will not try to say the second part of that name for fear of butchering it, but this mission launched on March 2004. And arrived at the comet in 2014, so just a year before Claudia died, and ended a year after she died in 2016. This mission was the first to rendezvous with the comet and follow a comet on its orbit around the sun, and the first to deploy a lander on the comet's surface. And we're astronomers and planetary scientists are very interested in studying comets, just because it'll help us better understand the history and evolution of our solar system, since they're one of the oldest objects. They're reminiscent of whatever was left over when our solar system did form. And on this mission, Claudia was responsible for 3 instruments that totaled up to about $35 million worth in instrumentation, and she also oversaw the tracking and navigation support from NASA's Deep Space Network. So if you haven't heard of that before, the NASA's Deep Space Network is the telecommunication wavelength range that NASA uses to communicate with all these spacecrafts that are currently in our solar system, and rovers and landers. Before moving on, there are of course more Black astronomers with many noteworthy discoveries and contributions to the field. However, for the sake of time, I did limit it to these, and but there are more, as I mentioned, and I think for the rest of this month I would like to continue posting some on our Twitter page, just to highlight the very important work that they have done. And before concluding and ending on to the virtual night sky show, I just wanted to go through and briefly discuss some of the Black astronauts, because you can't really think of space without thinking of astronauts. So first, starting with Guyon Bluford, he was the first African American to go to space aboard the third flight of the Challenger space shuttle, and his second mission was this 22nd mission of the space shuttle program, and the 9th and last successful flight of Challenger. His third was the 12th mission of the Space Shuttle Discovery, and his 4th was the 15th of the Space Shuttle Discovery. He spent over 700 hours in space before retiring in 1993, and was inducted into the U.S. Astronaut Hall of Fame in 2010, and he is now president of the Aerospace Technology Group. And second, we previously mentioned Ronald Mcnair, who unfortunately died in the Challenger disaster, and but did go to space and was the second African American to fly into space. The third is Fred Gregory, who was the first African American to pilot and command a space shuttle mission. In 2002, he became the first African American deputy administrator for NASA as well. and he was a part of 3 different space shuttle missions. Charles Bolden, he's veteran of 4 space flights and logged over 680 hours in space. He piloted the space shuttle mission STS-31, that was his second one, on the Discovery space shuttle that deployed the Hubble Space Telescope, which I thought was really cool. And he was administrator of NASA from July 2009 to January 2017. So almost a decade. And then we have Mae Jemison, who was the first Black woman to travel to space, where she served as mission specialist aboard the Space Shuttle Endeavour and logged over 190 hours in space. Next is Bernard Harris. In 1995, he became the first African American to perform an extravehicular activity, or for shorter words, a spacewalk, during the second of his 2 space shuttle flights. So during the second one on the bottom, oh, you cannot see my mouse, but during the second one was when he completed his first spacewalk. And next, moving on to Winston Scott, he logged a total of 24 days, 14 hours, and 34 minutes in space, including 3 spacewalks totaling 19 hours and 26 minutes, and was also a naval pilot and flew helicopters and Navy planes. Robert Curbeam was veteran of 3 space flights and logged over 901 hours in space. He currently holds the record for the most spacewalks during a single space flight, and logging over 45 hours during his 3 spacewalks during his final mission. Next, we have Michael Anderson, who unfortunately on his second mission died with 6 fellow crew members who were killed in the Space Shuttle Columbia disaster in 2003 when it disintegrated upon re-entry. Stephanie Wilson flew to space on board 3 space shuttle missions and was the second African American woman to go to space. She logged a total of 42 days, 23 hours, and 46 minutes in space. Wilson has been selected as one of 18 astronauts comprising the Artemis team, which is the mission scheduled for sometime in the next couple years. I think it's supposed to be this spring 2022, but I have not kept up to date with that. But Artemis is the mission that NASA is planning to send the first woman and next man to walk on the lunar surface. So she's selected as one of those astronauts, of 18 astronauts for that mission, for that team. Joanne Higginbotham flew aboard Space Shuttle Discovery as a mission specialist and is the 3rd African American woman to go to space and logged over 308 hours in space. Alvin Drew is veteran of 2 space flights, was part of the first Space Shuttle mission to the International Space Station in 2007. In 2011, he became the 200th person to walk in space and took part of 2 spacewalks while he was docked to the station. Leland Melvin played football and was chosen by the Detroit Lions in the 11th round of the 1986 NFL draft as wide receiver, but pulled a hamstring during training camp, and the following spring he reported to Dallas Cowboys but pulled his hamstring again, officially ending his professional football career. But then he ended up serving after his professional football career ended. He became one of NASA's astronauts and served aboard 2 space shuttle missions on Atlantis as a mission specialist, and then was named NASA Associate Administrator for Education in October of 2010. Robert Satcher participated in 2 spacewalks, logging in over 12 hours, and has both a PhD and an MD. Victor Glover was pilot on the first operational flight of the SpaceX Crew Dragon to the International Space Station, and he is the first African American International Space Station expedition crew member to live on the International Space Station and not only visit for a short stay. So all the other astronauts prior to him all the 14 ones sent prior to space before him were only there for brief visits, and he is the first to actually stay there for, I believe, longer than 6 months and live on the International Space Station, which is noted as like a notable achievement. And it was also noted that this is that NASA has a total of more than 300 astronauts, and he is the first to actually stay living on the International Space Station. And this was recent, like in 2020. And then we have Cyan Proctor, a commercial astronaut who was launched into Earth orbit in September 2021 as pilot of the Crew Dragon space capsule, and the first African American woman to pilot a spacecraft. Not included in the list of these NASA astronauts are Michael Strahan, who was the first African American space tourist that flew on the Blue Origin New Shepard suborbital spaceflight this past December. And also not included were 6 astronauts who never traveled to space, but just for sake of time and everything. But this does conclude the end of this portion of the show. So I hope you have enjoyed learning a bit more about the history of some historic Black astronomers and their incredible discoveries and contributions to the field of astronomy and planetary space sciences. And as I mentioned, in 2 weeks we will be hosting another show, and this time be featuring and highlighting the work of the next generation of Black astronomers, essentially my colleagues and peers that are in my program, as well as the greater Los Angeles area. So tune in, mark your calendars, and we will see you then. But in the meantime, we will now transition for the last 20 minutes of the show, or possibly less, depending on how it goes, to our night sky show, our night sky tour. Usually in the planetarium we have a projector, and we are able to show you what you can see in the night sky at the time. Since moving to YouTube Live during the pandemic, we have used the software called Stellarium. It is free. You can download it for Windows, for Mac, and I believe it's also available for mobile, although I have not used it myself. So I'm going to transition really quick to that software, and it might take a bit. Okay, there you go. And hopefully it'll update for you all soon as well. So the software is really cool. If you have been to our YouTube live shows, you have seen them before. It will give you, on your computer when you start it up, it will go in real time and show you the night sky, also in your area. So this is what the night sky looks like right now from the San Fernando Valley, right outside of the Los Angeles area. However, it does not actually look that clear because I had turned off the light pollution. So that's another benefit to this software, is that you can remove the light pollution, and you can also, well, first to talk about light pollution, if you're not aware, dark skies, there is light pollution, so just anywhere like cities, and the light does affect you being able to see certain things in the night sky. There are dedicated dark skies like Joshua Tree, where those areas are a lot darker and you can see things more. What is also interesting about Stellarium is that you can remove the atmosphere. So if you remove the atmosphere, you can see how much clearer it gets. And I just wanted to bring that up because I just wanted to bring that up because typically all the ground-based observatories that astronomers use are located on very high mountain peaks. And part of that reason is, yes, there's less light pollution, for one, but second of all, since it is at a higher altitude, the light from the sources we are observing actually has to travel through less atmosphere as well. So that's another reason why they're located at very high altitudes. And we also use space telescopes like the Hubble Space Telescope and the launch of the new James Webb Space Telescope, or JWST, because in space you no longer have to deal with the atmosphere. So it's a lot clearer. But now to begin our show, let us discuss a few things that are visible right now in the night sky. So what is cool about this as well is that you can set up different options. So right now I am going to have it, okay, this is for the different types. So if you go here to the side under sky and viewing options, you can actually have it show different types of objects. It'll fill your screen like this. For now, I'll go ahead and remove that, and I will use them once I need them. What I was actually looking for was right here, is that you can put constellation labels. And then, so right now, in the night sky, given the winter northern hemisphere, I just want to talk a bit about some of the constellations that are visible if you go out. So if you were to go out right now and look to your east, you can see some of the Zodiac constellations. So right close to the horizon on your east side, you would see the Leo, and then if you can continue diagonally across, further above, you can see Cancer, and then Gemini and Taurus. Those are the Zodiac constellations that are up right now. I'll go ahead and add the lines now so you can see them. So Leo, as I said, it's barely rising from the horizon, so it's starting to become visible. And then Cancer's right above, and then Gemini and Taurus right above. So those are some of the Zodiac constellations that are visible right now. Some other constellations that you can see right now are Ursa Major. It's kind of like this bear, right? And there's also an Ursa Minor. Ursa Minor. Okay, so sorry, I meant Canis. This is Ursa Major, which is supposed to be the Big Dipper, but I was trying to refer to Canis Major, which has Sirius, which is the brightest star in the sky. So if you were to go out right now and look in the southeast direction, see a bright star, then you can try to pull apart this constellation called Canis Major. Of course, you won't have those lines, so it'd be a bit more difficult. And along with Canis Major is also, let's see, okay, I was looking for the Little Dipper, but it must not be visible in this region yet. But it is visible in the winter northern hemisphere. So moving on to some more cool stuff. As I mentioned, that the Milky Way is currently on a crash course collision with Andromeda. So you can actually see Andromeda right now in the night sky. You can see the constellation and the galaxy, but let me go ahead and go back to the sky viewing stuff and go ahead and put these labels and markers. Let me take some of these off just so it's not as crowded. Oh, that's a lot. Okay, and now you can see, as I mentioned, it is pretty crowded, but things are labeled now. If there's anything that also interests you and you'd like me to zoom in on, please feel free to let me know. For some reason I cannot find Andromeda right now, so I will come back to that and move on to the Beehive Cluster, which is, if you look east right now and to the Cancer constellation, right above this point right here is something called the Beehive Cluster. And the Beehive Cluster, here we're able to zoom in. You would not get that kind of, you would not be able to see that with your naked eye. But the Beehive Cluster is an open cluster. You can see it like as, it'll look maybe like a smudge with your naked eye, or you'll be able to see some kind of like, smudge pattern, and it'll look better if you use like binoculars. or a telescope if possible. But I did want to talk a bit more about what an open star cluster is. An open star cluster is made up of a few thousand stars that were formed from the same giant gas cloud and have roughly the same age. So these open star clusters are key to stellar evolution studies, just because these stars are of the same age and chemical properties. So you can look at that part of the sky and know that they were all created at the same time. And if they were all created at the same time, you can try to learn more about how these stars evolve over time. And so, as I mentioned, this is called a Beehive open cluster in the Cancer constellation. If you have binoculars, it is more visible, and it is something cool to look at. There's a few more open clusters. Once you're looking at the Cancer constellation, if you look a bit further up, like northeast, into the constellation called Aruga, above Gemini, there's a few more open clusters. One of them is known as the Pinwheel Cluster. Right here. Again, this is, I guess, super cheating since I have this and would not have this out in the night sky. There are like Starfinder charts though, and also like cell phones now that let you do this. And the Pinwheel Cluster is a diffuse open cluster as well, and you need binoculars to see it. It is a lot harder to see this one with your naked eye. We'll zoom into it though and use the benefit of this software. So as you can see, it's an open star cluster. It's a bunch of stars grouped together. It contains at least 60 that are viewable and is viewable with like binoculars, as I said. With binoculars, it'll look kind of like a fuzzy patch, and it's 4,100 light years away from Earth. So that's pretty cool. Similar to the Pinwheel, in the same constellation, Aruga is the starfish cluster. So slightly right above it, right here. If you look at it, it's another cluster of stars, and these are also about 4,200 light years from Earth. And if you use binoculars, the cool part about the starfish and the starfish cluster and the Pinwheel cluster is that you can see them in the same like field of view of your binoculars. And with a medium-sized telescope, you could see that there's like an X shape of stars if you happen to own a small telescope. Moving on to the Orion Nebula. So zooming back out. Hopefully this doesn't make anyone kind of dizzy. Okay, zooming back out. Orion is one of the few constellations I can actually find on my own without any help, and that's because when you look up at the sky, well, first of all, it'll be east, and it is the way I always find it is through the orange star Betelgeuse right there, and then right below it you can see Orion's belt right there. And the Orion Nebula is found in this constellation. Once you find the constellation, you want to look underneath the belt, and it is a star forming nebula. So if you are able, it's okay, so it's supposed to be in the middle of the sword. Okay, the sword, okay, over here. If you're able to see this with, you can see it with binoculars, but you can actually see it with your naked eye too. It's 1,344 light years from us, and it's thought to be 3 million years old and home to some of our galaxy's youngest and hottest stars. If your eyes can see in the infrared, you'd see the dust and you'd see thousands of young stars and protostars that are hidden from our eyes in this stellar nursery, but I am currently trying to find it for you all. If you have any questions about the Orion Nebula or in general, please let me know. And the Orion Nebula is also known as M42. Okay, which I owe you all another one since I can't find it right now. Okay. But the cool part about that, and the main thing I wanted to point out with that one, is that it's a star forming region, so it's like a stellar nursery, which is pretty cool. We are very close to time, given that it's almost 8 p.m., so there's 4 more minutes. There's a few more things that I did have on my list, but a lot of them do require binoculars to see, or a telescope, other than the Andromeda Galaxy, which I did want to see. I did want to show you. So I will focus on finding the Andromeda Galaxy. And if anyone has any questions, please feel free to type that in the chat. Oh, found it. There you go. There's Andromeda Galaxy. So here, if you look west right now, if you were to walk outside and look west, you would see Pisces, the Pisces constellation, and then you would want to go just directly west. So I'm placing this wrong. Hopefully not giving any of you some crazy lip whiplash or dizziness on a screen with this. But right around here, you have the Andromeda Galaxy. And how cool is that? Wow, it looks really cool on the software. So the Andromeda Galaxy, as I mentioned, is the closest galaxy to us. It's 2.5 million light years from Earth and is the most distant object that we can see with our naked eye. And a better key, other than telling you to just look west, is to actually look for Cassiopeia. So Cassiopeia is this W-shaped constellation. One of my favorite constellation names. I have considered, I think it's a really pretty name in general. Anyways, and you guys, if you look for Cassiopeia on that edge right there, you're just going to want to go westward from that. And then you'll find the Andromeda Galaxy, and it'll look extremely faint with your naked eye. But if you have binoculars, you'll see what looks like a cloud. And what's pretty cool to know that is that if you look at that, like with those binoculars, look into that cloud, is that you see a whole entire galaxy, and one that it's on its way on a collision course with the Milky Way, and will soon become one big elliptical galaxy. Well, by soon, it's like 5 billion years. So I was able to find what I was really hoping to. Let's see if I go back to the Orion Nebula then. If I can find the... Okay, now I'm getting myself dizzy. Here's Orion, so here's his arch, and where's his sword? There's a bunch of clusters in general though, so if you ever are curious, you could definitely look either on the software or online, and just remember that like star clusters, it's just a bunch of stars that are together and were created at the same time, and our astronomers use to study stellar evolution. What I did not mention was a globular cluster, just simply because you can only see it with like a telescope, and it's in Lepus, and it's called M79. But I will cover what a globular cluster is, just like as a fun fact. They're different than open clusters, so they are still a group of stars together, but Their origin, and their role in galactic evolution is still unclear and an area of research in astronomy. They're some of the oldest objects in their galaxies and even the universe. And as I mentioned with open clusters, star clusters are often assumed to have stars that formed at the same time from the same gas cloud, but nearly all globular clusters contain stars that formed at different times or have differing compositions. So there's still a mystery to astronomers, and the one that you need a telescope for is called M79. Anyways, I will go ahead and close up here. And the main thing to know that is if you are outside in a darker sky, the constellations you can see right now are Taurus. You can see Taurus. You can see Cancer, Pisces, Gemini, and you can also see Orion. You can see Andromeda Galaxy, which is really cool, and the Little Dipper, the Big Dipper, and the Canis Major and Canis Minor. To find those, just find Sirius, the brightest star in the sky. Okay, everyone, so it is 8, so I will go ahead and get wrapping up. If you have any comments, questions, go ahead, feel free to use the chat or the comment section at the end. But thank you so much for joining, and I hope you enjoyed the show. And as I mentioned, tune in 2 Wednesdays from now for another show where we'll be celebrating Black History Month and highlighting the work of some of the grad students and their research that they're doing here in the greater Los Angeles area. We also have a show next week as well on a different topic, but in general, stay in touch on either our Twitter page. We have a Twitter page, we have a Facebook page as well, and we also have a website for any updates. Thank you, everyone. I hope you have a great Wednesday night and a fantastic Thursday morning if you're watching this live. If you end up watching this after posting, then I hope you have a great night, day, whatever it is. Bye-bye.